An explosion breaks an object into two pieces, one of which is 1.5 times the mass of the other. If 7,500 joules were released in the explosion, how much kinetic energy did each piece acquire? This one's a tough one. I wanted to throw this in there as kind of a challenge. And in order to do it, you're better off not jumping into the mathematics too quickly. As you can see, there's only like two numbers in this whole problem, so it's not really an exercise of mathematics and calculation on this one. Your physics intuition is going to take you a lot farther. And for that, I want to remind you of the lab that we started all this stuff with. So this is a repetition of the lab that we did in class. We started out with two masses, and in the simplest case, you had 1 kilogram here and 2 kilograms there, and the total momentum was 0, but there was some energy stored in the spring that was in between them. Then when the spring exploded, I just made these numbers up. If this one went to the left at 4 meters per second, then in order to make the momentum still add up to 0, this one had to go to the right at 2 meters per second, right? Because this one's got 4 momentum to the left, so that one's got 4 momentum to the right. So it all adds up. Now, turn your attention over here and look at the kinetic energy going on. So to add up the total kinetic energy, the energy that was in the spring at the beginning, you just do 1/2 mass times velocity squared for the green one, plus 1/2 mass times velocity squared for the yellow one. It turns out the green one had 8 kinetic energy, and the yellow one only had 4 kinetic energy, to give it a total of 12. So even though the momentum was distributed equally between these two carts, that was definitely not the case for the kinetic energy. And that makes sense because the formula for kinetic energy is 1/2 mv squared. And since the v ends up getting squared, the one with the larger velocity and smaller mass gets favored in terms of the energy. Okay, sorry, I got sidetracked for a while and forgot where I was. But if you look at the momentum is equal on both of the blocks. They both get a momentum of 4. But the kinetic energy was not distributed equally. The green one got 8 and the yellow one got 4 for a total energy of 12. But check this out. If you look at how the energy was distributed, the green one ended up having 1/3 of the mass, right? The total mass was 3, and the green one had 1/3 of the mass. But for the kinetic energy, it had 8 out of 12. It had 2/3 of the kinetic energy. Likewise, the yellow one had 2/3 of the mass, but 1/3 of the kinetic energy. So to use some fancy physics stuff, the amount of kinetic energy that each object receives is inversely proportional to its mass. In other words, you get more mass, you end up getting less of the kinetic energy, which makes sense because kinetic energy is 1/2 mv squared. All right, so now that we did this entire problem that is entirely different from this one, let me reset everything and talk about this problem in the same way. Okay, so to the original problem. Now that I explained all that stuff in great detail, this one's going to be pretty darn easy to figure out based on what I said before. If you look at the total mass of both, you've got 2.5 kilograms of stuff to play around with, or whatever the unit is. You got a total M of 2.5, of which the green one takes up 1.5 out of the 2.5, and the yellow one takes up 1 out of 2.5. Let me kind of rewrite that as a percent because that might make a little bit more sense. So this one comes out to be 60% of the mass, and the yellow one comes out to be 40% of the mass. And obviously those two add up to 100% to make the whole system. So check this out. If you look at the two, the green has 60% of the mass, and the yellow has 40% of the mass. But from the problem before, the energy ends up just switching places. This one hogged all the mass, so that one ends up hogging all the kinetic energy because velocity is more important. So all you got to do is just this. So if the green one had 60% of the mass, then it's going to have 40% of the KE. So 40% of the 7,500 KE to work with is 3,000, which means the yellow one's got to have the leftovers, 4,500, and the units for both are joules.